Hello guys, welcome to Theory channel. In this video, we're gonna solve the fifth question in Sipser textbook, and this question also is about DFAs, regular languages, and that's it. Let's solve it together. Okay, as you can see here, the fifth question is that each of the following languages is the complement of a simpler language. In each part, construct a DFA for the simpler languages, then use it to give the state diagram of a DFA for the language given. In all parts, our alphabet is A and B. First of all, let me show you something about complement. Okay, as you can see here, and actually this is a definition about the complement. Since languages are sets, the union, intersection, and difference of two languages are immediately defined. The complement of a language is defined with respect to sigma star, that is the complement of L is equal to sigma star. And as you can see here, actually, if I want to explain this, our whole strings is actually sigma star, and if we want to define the L complement, we have to choose every string except L in there. And as you know, actually, the complement, actually the regular languages are closed under the complement. But how? If you have a DFA like this, actually, I don't know, actually like this. Yes, and this is our acceptor state. If I want to choose the complement of this language, I have to replace every state with acceptor state and replace the acceptor state with a normal state, like this actually. This will become our acceptor state here. We will keep the transitions, and this one will become a normal state. All you have to do is replace the states together, and that's it. Let's solve this question. Our first part is that W, actually, let's write it here. Yes. So part A is that W, and W does not contain the substring AB. W does not contain the substring AB. Yes, so this is our language, and this is equal to L. So L complement is something like this here. W does, actually this one contain the substring AB, and that's it. Let's first draw the DFA for the complement of L, and it will become something like this actually. Let me show you. It will become like this. We must have a substring AB in our string, so first of all, it will become like this. If we have AB, as you can see here, we will go to our acceptor state, that is here, and we will draw other transition here. Here is A and here is B, and this is the DFA for L complement. So now for actually L complement, actually, now let's define the DFA for L. And yes, all we have to do is that replace all of the state with acceptor state, and replace all of the acceptor states with a normal state, and it will become like this. We will keep all the transitions, actually, here A and B, and A and B, and our normal states will become our active state here, and our active state will become the normal state. So this is the DFA for L, and that's it. That's all you have to do. Now let's go to part B. Part B here. Part B. It says that W does not contain the substring actually BA. So this is L, and the L complement is something like this here. W does contain the substring BA. Oh, sorry here. And it will become like this. Yes. Now, first let's construct a DFA for L complement, and it will become actually like this for L complement. Here, this is for L complement, and this is actually something like this. We have this transition here, and after that we have an A and B, and finally A. And we have these transitions, and actually this one is a little tricky here because it must contain a bigger substring compared to last one, and this will become like this. Yes, and yes, okay, and our active state in here is this one, and that's it actually. So this is the DFA for L complement. As you can see here, it will contain all of the string that has BAN as a substring. As you can see here, first we have a transition for B. Let me show you B here, and after that we have a transition for A, and after that for another B, and finally for another A. And in the middle, actually, if you go wrong like this one, if you choose B, you will back to the previous state, as you can see. And that's it. Now all we have to do is actually change all of the states, so it will become like this. Here we will keep all of the transitions, actually B and A, this one A and B, and finally A, and this we will have this one and this one, and our active states are this one and this one and this one and this one, and that's it. This is the DFA for L, and that was the answer for part B. Let's go for the answer of part C here. For part C, and the part C says that actually W contains neither, actually here. This one is new. Neither the substring actually AB nor BA. So this is for L. Our L complement actually is something like this. Let me show you. Actually W contains actually now either, and sorry, actually here either the substring AB or BA. And that's it. Let's construct the DFA for L complement first. For L complement, our DFA actually here is something like this. Here, if we start with A, it will become like this. And if we start with B, actually here, A and finally A and B, it will become like this. And these are our acceptable states. As you can see, if I want to explain this DFA for you, it's that if we start with A, we must have the substring AB in our languages. So we construct the AB here, actually here in this part. And if we start with B, we must have the BA actually as our substring. Let me define it with red color here. And it will become like this. Now let's construct the DFA for complement of this, and it will become actually like this here. If we start with A, here we have, here B, and finally, and we have to keep all of our transitions. And if we start with B here, actually, yes, here B and here B, we have these transitions, and we must replace all of the states. So our new acceptable states are these ones. And yes, this is for L, and that's it. Okay, now let's go for part D here. Part D here actually says that W is any string, actually not in A star and B star. Yes, that's it. So this is L, and our L complement is that W is any string actually in A star and B star. Now let's construct the DFA for L complement. For L complement, our DFA will become like this, actually, as like this. If we start with A, actually this is our acceptable state, and if we continue with B, this is also our acceptable state here. And if we see another B's, we will stay here. And finally, if we see an A after B, we will go to normal state, and this one is not our acceptable state. And this is the DFA for L prime. As you can see here, it will accept all of the string that's in actually A star and concatenate with B star. And now let's construct the DFA for L, and it will become like this actually. Here A and B, and B, another A, and our acceptable state now is this one, and all of the previous acceptable states will become the new normal states here. And that's it. That was for part D. Let's go for part E here. For E, we have the part E says that W that W is any string not in a B plus star. Actually, this one is a little tricky. This is the L complement is that actually W that W is any string in a B plus star. It's like this. Now let's construct the DFA for L complement. For L complement, we have actually, and actually here this one is little tricky. As I said before, it will become like this. It has a strange shape for DFA. We know that this string actually contains epsilon, so the first state is our active state here. If we continue with A, we will reach this part here. And after that, if we see A, it's not our active state because we must have just one A here. So if we say A, we will reach here. And if we start with B, this one actually is not our accept because we must have an A in a start of our string. So here we have this transition, and after that, if we see A or B, it does not matter. We will never reach the accept state. But here, if we start with an A and after that we see B, or better I say B's, we will reach our accept state. Just notice that we have a star here, so we can see this pattern actually multiple time like this actually, A, B, and A, B. So we must have a transition for 8 that it will actually with it we reach this state and we will continue with B. Actually we stay in a loop and we see A, B, and so on. That's it. This is the DFA for L prime, and now let's construct the DFA for L. For L, it will become like this. Actually, we have A, we have B here, and here. If we see A and B, we will stay here. And finally, if we see B, we reach this part. And after that, we have B here and A here. We must replace all of the accepted state with normal state and all of the normal state with accepted state, and it will become like this one. So this is the DFA for language L here. And yes, sorry, I forgot one thing here, A, and yes, that's it. This was for part E, and now let's solve the part F here. For part F, we have actually for part F and W, that W is any string. W is any string not in A star union with B star. This is L. The L complement is that W is any string again in A star union with B star. And yes, that's it. Let's construct the DFA for L complements first, and based on that, we will construct the DFA for L complement. Here, our DFA is something like this. As you know that the union of A star with B star contain the string epsilon. So our first state is our active state here. And after that, if we see A, actually better I say that if we start with A, we must just have A in our string. So here, this is our active state, and with another A's, we will stay there. And if we see just one B, we will reach one state that is not our active state here. And if we start with B, and we are in this part that we must have only B in our string, so it will become our active state. And if we see another B, we will stay here. And if we see just one A, we will reach this state. And after that, this is not important. We will stay there and we will never reach the active state. So yes, this is the DFA for L complement, and now let's construct the DFA for L. For L, all we have to do is that change the states. Sorry for this line here. A and B, and this one A, this one B. And after that, if we see A here or B here, we will reach this state. And in this DFA, our active state is here, and all of the other states are normal state for us. And yes, that's it. That was for part F, and now let's go for part G. For part G, actually, we have, for part G. For part G, we have W, that W is any string that doesn't contain exactly 2 A's. And this is L, and our L complement is that W is any string that does contain exactly 2 A's here. Yes. Now let's construct the DFA for L complement, and it will become like this. For L complement, we have this DFA here. If we see A, actually here the number of B is not important. So anytime we see just one B, it will stay in our state, and we will not go to our next state. So the number of B is not important here. So we have a transition for B here, and as you can see, after that we reach 2 A's here. So this is our active state, and this is a transition for B. And after that, if we see other A's, we will pass 2 A's. So we reach this state that is just one normal state, and it will become like this. Yes, this is the DFA for L complement. So for L, we have a DFA like this one here, and A and another B here, and finally this transition. And our active states are these states, and that's it. This is the DFA for part G. And now let's solve the final part, is that part H. As you can see, the part H says that actually W is any string here except A and B. This is the L, actually the L language. The L complement is that W is here any string. Actually, better says that W is A and B. And B. And that's it. This one actually here is so simple. We know that if we start with nothing, we will reach this part, and if we see A or B, it does not matter. We will reach the second part. That is our active state here, actually. Sorry for L complement, because it says that W is A and B, and this is true actually. And after that, if we see A or B is not, it does not matter. We will reach this state that is not our accept state. So this is for L complement, and if we want the DFA for L, all we have to do is that change the states. So it will become like this, yes. And these will become our new accept states. And yes, that's it. Let's review the last part. W is any string except A and B. So our string actually is like this. We can have A or I don't know AB, BA, BB, and all we can't accept is A or B. And yes, this is correct. Yes. And that's it. We solved the fifth question in Sipser textbook. I hope you guys enjoyed this solution actually here. If you like this video, drop a like for me and don't forget to subscribe to my channel. If you have any comment, actually leave it for me. I will read all of the comments, and thank you all guys. I hope you enjoy and actually learn something about DFAs. I know this part might be a little tricky, but with practice you will learn it. And that's it guys. I hope you enjoyed this video. Have a nice day. Bye.